Hi, this is Lisa. In this video, I'm going to talk about applications of factoring. The first one is domains of rational functions. Remember, the domain is the set of all x values. A rational function is a function with a variable in the denominator. When you're trying to find the domain of a rational function, you have to remember that fractions are undefined when the denominator is 0. So we are concerned with what we have in the denominator, and we want to make sure that it's not equal to 0. So to find those values, we set the denominator equal to 0 to determine which values make the function undefined. In step 2, the domain is all x values except those values we just found. So we write the domain using set notation, set of all x, such that x is real and x is not equal to a being those values that make the denominator 0. So let's do some examples. Example 1, find the domain of the following function. So I have to look at what makes the denominator equal to 0. X squared minus x minus 6 equals 0. Now this is a nice trinomial with a leading coefficient of 1, so I know x squared factors as x times x. Negative 6, when I look at it, factors are 1 and 6 or 2 and 3. To get the negative sign, one of those numbers has to be negative, and I need to be concerned also with my middle coefficient here being negative 1. If I have a positive 3 and a positive 2 and a negative 3, my middle coefficient will be negative 1. So plus 2 minus 3, and it's equal to 0. Set each factor equal to 0 and solve for x. Subtract 2 from each side of the equation, x equals negative 2. Add 3 to each side of the equation, and I get x equals 3. So my domain is equal to the set of x such that x is real and x is not equal to negative 2, 3. We'll do a couple more examples. Find the domain of this function. Again, we're concerned with what makes the denominator 0. X squared minus 4 equals 0. This is a difference of two squares. It's x squared minus 2 squared. Difference of two squares, a plus and a minus. First thing being squared is x. Last thing being squared is 2. And to solve my equation, I set each factor equal to 0. Subtract 2 from both sides. X equals negative 2. Add 2 to both sides. X equals positive 2. So my domain is the set of all x such that x is not equal to negative 2 or 2. Our next problem is an application or story problem. We're going to solve this problem. A rectangular flower bed is to be 3 feet longer than it is wide. The bed will have an area of 208 square feet. Find the dimensions of the flower bed. When they ask for the dimensions, that's the same thing as asking you to find the length and the width. So we're going to start our word problems. We always start by translating each sentence that we've been given. So it says a rectangular flower bed is to be 3 feet longer than it is wide. So the length, our length is going to be 3. Longer than means plus the width. The flower bed will have an area of 208 square feet. So area is 208. Units on individual dimensions like length and width, the units here are feet. When we talk about area where we're multiplying length times width, we get feet times feet or square feet. Doesn't mean we're squaring the 208, it just means the units are squared. So our formula for area is length times width. They gave us that the area is going to be 208, so I'm going to plug that in. The length is 3 more than the width, so in place of length I'm going to put 3 plus w, and then from the original formula I still have w. I need to distribute to get rid of my parentheses. 208 equals 3w plus w squared. In order to solve these equations, I want everything on one side of the equation, so I'm going to subtract 208 from both sides. The other thing I'm going to do, because it makes it easier to factor my trinomial, is put it in descending order. I have a positive w squared. My 3w is positive, so I'm going to say plus 3w, and I have minus 208. And now I can try to factor that trinomial. Again, this is a relatively easy one to factor because we know w squared factors as w times w. Negative 208 is a relatively large number, though. I'm going to show you a trick for factoring. I'm going to use my calculator. I'll go to the y equals screen, and I'm going to hit clear if there's something in there, and I'm going to do 208. Actually, I can do negative 208 divided by x. And what happens when you divide by x and then look at the table, so remember, table is second graph, and it's going to show me all the pairs of values that I can have. At 0, I get an error because I can't divide by 0. But if I look down here and I look for integer pairs, 4 and negative 52, will that add up to give me the correct middle term? No. So I'm going to scroll down my list of values here until I find the combination. Let's see, 13 and negative 16. That almost works, but it gives me the wrong sign. So I'm thinking, that's close. What do I have to do to change that so that it's the right one? 13 and negative 16. If I make it negative 13 and positive 16, I will get a positive 3. So in my parentheses, I want negative 13 and positive 16. Set your factors equal to 0 and solve. I'm going to add 13 to both sides here, and I get w equals 13. I'm going to subtract 16 from both sides here, and I get w equals negative 16. When you're measuring something, the width cannot be a negative number. When we measure, when we're doing these application problems, we always want positive dimensions. We just said the width is 13. If I scroll back up here, I had a definition for length, right? I said the length is 3 more than the width. So once I have found the width to be 13, then I can say length is 3 plus the width. 3 plus 13 tells me my length is 16. So I now have a width and a length. The units that we were using were feet, right? The width was 3 feet longer than the length. So we want to include our units here for length and width. And that concludes this video.